All right, so usually when you talk to like any astronomer or cosmologist about what they might think the hardest part about gathering information about like flying planets or any object in space, you name it, I always used to say that the hardest thing about any kind of traveling to an object, trying to figure out its orbit patterns, is trying to get into its surface. Because some planets will not let you get into their surface because they have it's just the pressure and the magnet field that just destroys everything. And that's even before you hit the atmosphere portion. It's like, as you're entering the atmosphere. There's a reason why some planets to this day they're still speculating what they might look like on the inside, even though we kind of have reasons to believe what probably is going down there. But it is interesting to think, like, I was looking at Neptune, for example, most importantly, Neptune, because Neptune is a planet that even if you could get really close to it and it didn't destroy everything from, like, kind of like Jupiter, the pressure destroys it even before you even hit its atmosphere. And that's even before you even start talking about the solar winds and the great storm and the thick clouds and whatever that material is made of. If you really want to get technical, there's even even Neptune's like got like worse winds. They're like 1,500 mile an hour winds would blow everything around. So it's unless you have like something that's a weight like that can weight that satellite down and it's gonna hold its balance. It's not gonna break it. I mean, you might get lucky and you might be able to land it in there, but you still have the thick clouds and then it rains diamonds, I believe. You really have to study a planet multiple times before you really understand what's a good way to go in there and try to get some pictures of it of some kind. But it's, at least it's better than trying to attempt to land something on Venus and then watching it disintegrate. But at least you can see what its atmosphere looked like at its surface. You know, Obviously everything's melted and gone, but now it's like what was there at one point? Same thing with Mars. Those are, Mars and Venus are the two closest planets to us, and it seems like they don't have any trouble like showing pictures off like what those look like from their surface because we've been able to land on them successfully. But something like Saturn, Uranus, Neptune, Pluto. Well, maybe Pluto they've landed on. I would believe. But I just think it's really interesting. There's so many, like if you have a planet that you can't just see its surface, but like let's say like you have an atmosphere you got to penetrate through, you basically have to understand that you have to really figure out like how you're going to get there, and you're going to have to figure out how to get in. And it just goes to show you that even with a telescope, you could see a planet far away and you'd be able to identify it, but to see right through it is a whole nother story. And obviously that means that even more powerful telescopes and how fast everything moves in space and far away or closer depending on the angles and the coordinates. It just goes to show you that there's just so much we don't know and so much that we could still do that we need to understand still. So I've seen a lot of people often ask that question. Why is it that there are some planets out there that are really hard to like observe completely? And that'd be why, because there's such big objects in their mass and their physical properties are enough to destroy anything that we basically send its way. Let alone some of these planets they take forever to get to, so it's even harder to really calibrate, how old they are, what they're made of, what their future lies. Like I'll give you another example just to, give off too. You've got like Jupiter and Neptune that are said to have planetary storms that are so bad and they've been going on for so long. I think Jupiter's is longer, like its great spot, for example. They say it's cooling down a little bit finally, but it's still violent nonetheless. But some of these planets, what really blows my mind, and I think the reason why I've always been obsessed with wanting to know if these planets are solid, is like, what if they don't have a core necessarily? Like, if you really look at into it, like Jupiter is said to have a core, and so is what is it? Neptune. But it's like, but it's possible that maybe it's just a fragile one because because it's so big and its pressure collapses on itself that it basically makes it too soft. So you basically could fly right through the planet, if that was possible. It's crazy to think that, imagine just this big ball of gas flying around in space, but yet it looks like it can still maintain some kind of a spiral form and whatnot that it causes it to look the way it does. And it's just interesting to think about like how many things we still have yet to learn, and the stuff that we've been able to examine based on satellite ratings of just about something that just runs around in space and all that. So it gets caught in its orbit, and then eventually it's beaming down transmissions what could possibly be underneath it, and what we could figure out about it. And that's just like how the stuff we've been able to figure out nowadays, like with satellite probes and all that. Again, sending it through space and being able to get it out there, dodging asteroids, dodging, You know, it's just crazy to think like how we've been able to get from the inner planets to the outer planets just like that. You know, somehow. It's interesting. I think it's crazy how we were even able to send probes out to Pluto, and where and how far back they were able to transmit back here. You know, it just goes to show you that our wavelengths can still be picked up somehow. But that's very astonishing indeed. It's not bad for a galaxy that might roughly be 1.9 million light years in diameter, or even more. You know, and that's even before it starts colliding with the Andromeda galaxy and how big that planet might, or that galaxy might be. Just goes to show you, you know, how big are these things, these objects. So much we don't know, but it's like there's so many possibilities. And again, like Carl Sagan once said, you know, somewhere something incredible is waiting to be known, somewhere beyond the cosmos. So yeah, that should kind of explain it a little bit better. Why some people like are trying to understand why some of these planets really are hard to observe. Some of them are really thick in diameter. Some of them you can't even land on them before they just destroy the craft instead. Or so you really got to think like, how can we build something that can survive that? You know. So yeah. Anyways, so again, if you like these kind of videos, please subscribe. If you have any requests you want me to talk about, let me know. If you want to donate to Patreon to make this possible to be a full-time job one day, you more than likely can. Or if you want to send me an Amazon gift card, message me. We can talk about something. But anyways, if not, you know, that's understandable too. But thanks for supporting this channel either way. Have a nice day.